Hey, sunshines. So today we're going to talk about section 9.3, arcs and central angles. It's 9.3 in your textbook. On Math Excel, it's in section 10.6. So it's part of a chapter that involves area in Math Excel. So it's a little out, but in Math Excel, it is section 10.6. And I'll write that up here. Math, if I could spell it, Math Excel, section 10.6. So don't be surprised. And then there really weren't enough problems, so I'll probably ask you to do some extra stuff. So section 9.3 talks about arcs and central angles, other parts of a circle that we want to talk about. So if you already looked at the notes for section 9.1, then these definitions are something that you should already have. You should already have this definition of a circle, the set of all points equidistant from a given point. The radius, a segment that starts at the center and has an endpoint on the circle. Congruent circles have congruent radii. Remember, that's plural for radius. A diameter is a chord that contains the center of the circle, right? It has endpoints on a circle, but it also passes through the center of the circle, which is the most important part. I know you studied radius and diameter before. A central angle is something that you may not have seen before, but a central angle is an angle with a vertex at the center of a circle. This particular definition is really important because we're going to learn about other types of angles as they relate to a circle. And the central angle is one of them, but there are other types. So if you don't distinguish between a central angle with a vertex at the center and then some of the other types coming up, then you're going to have a hard time. So we'll try to do each of that. I'm going to also suggest that it's probably not a bad idea if you print the notes, print the blank notes, and then try to fill them in as you listen to the video, and then pause the video every now and then. See what you can do on your own, especially with things like this, because there's a lot of you that can do stuff on your own. And I'm going to drag this down a little bit so that you can try to name the things that you need to name here. So we're going to name each of the following, and we're going to use proper symbols to the best of our ability. Okay, but this is a good time really for you to pause, try to do it on your own, and then go back and check. Got it? Okay, so this would be circle P. We always name a circle by its center, and the symbol for circle looks like an itty-bitty circle with a dot in the middle of it. Okay, radius could be segment PA, or segment PB, or segment PC. They are all radii of a circle. Each one is a radius. Diameter is segment AB. Remember that you could say segment BA. It doesn't make any difference, but pay attention to the fact that that diameter really does pass through the center P of the circle. If there is a dot there in the middle, then that is indicative of the fact that it actually is the center of the circle. If there's no dot, then we're not going to make any assumption about that, okay? So a central angle, I'm going to see if I can move this down a little bit. A central angle could be angle APC, or it could be angle CPB. Yes, there is a central angle that is a straight angle, angle APB, and that's fine. You can talk about that one if you wish. But if you're looking at this circle, angle APC is an acute angle right here, and angle CPB is an obtuse angle over here. If you really want to talk about the straight angle, then fine, you go ahead and name it on your own. Okay, we're going to move on to the next page. Okay, so an arc is a part of a circle. That's another definition that you need to know. An arc is a part of a circle. It doesn't include any of the points inside the circle. So an arc cannot include the center. It can't include any points that might be on a radius that are inside. An arc can only actually include points on a circle, like point R all the way around here to point S. Arc RS, that's an arc. Okay, sorry, that was just identifying a particular type of arc, but I'm going to erase that because the first type of arc we're going to talk about is a semicircle. So a semicircle is half of a circle. Obviously, based on that prefix, you probably understand that already. And the measure of a semicircle is really half the degree measure of a whole circle. So you think about if you were driving in your car and you did a 180, then you would be turned around facing the opposite direction, right? So a semicircle, arc TRS, is a semicircle like this. You can name a semicircle with just the endpoints of a diameter. I just don't recommend it. I do recommend as much as possible if you have 3 points to name a semicircle, then go ahead and do that because it tells you the direction that you're traveling in on the circle. But we can talk about arc TRS as a semicircle. It starts at T and it continues in the direction of point R, and then it passes all the way around to S. That would be a semicircle. Now we're going to talk about a minor arc. A minor arc is less than 180 degrees. So a minor arc measures, and I'll put that in here, measures between 0 and 180 degrees. This is different from, say, something like an acute angle. So a minor arc measures between 0 and 180 degrees, and a minor arc is named using only 2 endpoints of the arc. So we're going to talk about point R, and we're going to travel towards point S. And we're not going to go around the other way since we're talking about a minor arc RS. We're not naming any points in between that, okay? So arc RS is a minor arc, and there's some information underneath there about how the measure of an arc is related to its central angle. We'll talk about that in just a second. So the major arc. Let's talk about a major arc. A major arc measures between 180 degrees and 360 degrees. Okay, so the measure of a major arc is between 180 and 360. When you name a major arc, please use 3 points. That's kind of a requirement. That helps you distinguish between whether something is a major or minor arc if you're not necessarily looking at a picture. It also tells you the direction that you're traveling on the circle. So we're going to talk about arc RTS. So we're going to start at point R. We're going to travel in the direction of T. So if I went clockwise, I would hit S before T. If I go counterclockwise, then I'm going to hit point T first, and then I'm going to continue around the circle until I get to point S, and then I'm going to stop there. And so arc RTS is a major arc. Got it? Okay, and generally you can say that the measure of a major arc is 360 degrees minus the measure of a minor arc, just in case you were wondering about that. Something that you need to know, we'll talk about the finding measures in just a minute, but what you should know, and I'll have to check and look and see if it's on the page again, but the measure of an arc, especially of a minor arc. So maybe we should indicate that specifically. The measure of a minor arc is equal to the measure of the central angle that cuts that arc. So I mean it cuts it in the same points like R and S. It's not very good vocabulary, but here's what I mean. So the measure of arc RS right here is going to be equal to the measure of angle RPS. So if this is 100 degrees, then the measure of this arc is also 100 degrees, just like that. Got it? Okay, so again, this is a good place to pause the video for a second and try to identify some minor arcs and semicircles and major arcs. I'm going to list a few. Some minor arcs could be arc AD, arc AC, arc CE, and arc DE. Got it? Okay, some semicircles that you could name. Remember that a semicircle, in order for you to identify a semicircle, you have to be clear that the endpoints of your semicircle are endpoints of a diameter. So how do I know that? Well, I know that O is the center of the circle because there's a dot there. So I know that point D and point C are endpoints of a diameter, and also point A and point E are endpoints of a different diameter. So I'm going to say arc DAC, that's starting at D and heading around the circle through A until I get to C. That's a semicircle. And if I go the other direction, I could say arc DEC is another one heading in the opposite direction. Okay? All right, then I'm going to erase those for just a second so that you can see the other ones. So I'm going to take that away, take that away. And if we want to talk about arc, another semicircle, arc ACE right here, arc ACE, and arc ADE right here, arc ADE. That's another good one right there, okay? Alrighty. Some major arcs. So this is going to get a little more troublesome, and I'm going to have to erase these semicircles right here. So I'm going to clear that and clear that because there's definitely a lot of major arcs, and I'm probably not going to name every single one. But a major arc, the key thing is make sure that it's bigger than a semicircle. Okay, so if we start at point, let's say we start at point D, and we go through A and through C and around to point E, that would be a major arc. I'm not going to name it with all 4 points. I'm just going to name it with 3. So we're going to call that arc D, A, E. I really should not have used yellow, I'm sure. So arc D, A, E is the one that I'm talking about right there. And we can talk about other arcs if you wish. We can talk about arc, let's say you want to talk about arc A, D, C. You could talk about that one. That's another major arc. Arc A, D, C. And it's the same if you call it arc AEC. Sorry, excuse me. I just wrote arc AED when I meant to write arc ADC. And I'm sure that there are others that you can identify. Just in the interest of time, I'm not going to go through and identify more. But of course, there definitely are other ways that you could name them and different points that you could start at. So it's not a big deal. All right, we're going to move on to the next page because I only have a few minutes left before we need to start a conference. Okay, adjacent arcs are arcs of the same circle that have exactly 1 point in common. You know what adjacent sides are. They share an endpoint, so adjacent arcs also share an endpoint. So if you want to talk about adjacent arcs, they're arcs that are next to each other. So arc AB and arc BC are next to each other. Notice that they have point B in common. So if you start at A, go to B, and stop there and talk about arc AB, and then start at B and go to C, then also same thing. So why do we talk about that specifically? So that we know that the measure of a larger arc is equal to the sum of the parts, just like angle addition postulate, just like segment addition postulate, arc addition postulate. If you add up the parts, if I know the measure of this arc and I know the measure of this arc, then I can find the measure of the whole entire thing by adding those parts together. That's it. It's as simple as that, okay? It's not designed to be more complicated. All right, so let's find the measure of arc RP and let's find the measure of arc RPQ. Here's what I notice when I look at the circle. I've got 3 arcs. I don't really care whether they're major or minor, but I see 3 distinct arcs. I see arc RP, which is something I want to know. And I also want to know the measure of arc RPQ, which would be this whole entire arc over here. So I'm going to put another question mark there. Maybe I should put that in a different color. So I'll put that one in blue so that maybe we know we're finding the different arc right here. Okay? All right. I don't really know or want to know the measure of arc RQ. But here's what I noticed. There are 3 arcs that make up the entire circle. And what's the degree measure of the entire circle? That would be 360 degrees. So if I say that the measure of arc RP plus the measure of arc PQ plus the measure of arc QR, I add all 3 and set it equal to 360, then I should be able to find it. Again, this is a great time for you to pause, see what you can do on your own, and see if you can check your answer and get the same thing. Then I'm going to plug everything in. X plus 40 plus 3x plus 20 plus 2x plus 60 equals 360. Add like terms together, and I get 6x. And then 40 and 60 is 100, so this is 120 when I combine this term and this term and this term, and it's equal to 360. Then I'm going to subtract 120, 6x equals 240, x is equal to 40. Got it? So now I know what x is, but that doesn't tell me the measure of arc RP. Remember that the measure of arc RP is equal to x plus 40. So that's where I'm going to plug in the 40 for x that we just found and say that the measure of arc RP is 80 degrees. Arcs are measured in degrees. In a couple of years, you're going to learn that arcs can be measured in a different form. So now we're going to find the measure of arc RPQ. Well, we already know that RP, the measure of arc RP, plus the measure of arc PQ, right? We already know that this is 80, so I'm not going to go back and do that again. Excuse me. And then plus the measure of arc PQ, which is 3 times 40 plus 20. I'm kind of running out of space here. So this is the measure of arc RPQ is equal to 80 plus, that's supposed to be 3 times 40 plus 20, which is 120 plus 20, which is 40, right? And so the measure of arc RPQ is equal to 220 degrees. And then you're done. And that's it. And I know we could find the measure of arc RQ, but I'm not really interested. It just wasn't something that the problem was asking for, if you're paying attention. So I'm not going to do that piece. Let's see what's on the next page. All right, a great time to pause and see what you can do on your own. We're going to find the measure of each arc in circle O. So I'm going to have to be quick about this. I'm going to remind you that the measure of a central angle is equal to the measure of, the measure of an arc is equal to the measure of the central angle that cuts that arc off. So measure of arc BC is 32 degrees. And just keep in mind, O is the center of our circle. So we should remember that segment CA is a diameter, okay? That's important. Now we're going to find the measure of arc BD. Well, we just got this to be 32. So the measure of arc BD is going to be equal to 32 and 58 is 90. Got it? And then the measure of arc ABC. So we're starting at A, right? And we are traveling in the direction of B. So we got to head towards B first, and then we're going to stop at C. Well, remember, AC has endpoints that are the diameter of a circle, so that must be a semicircle. So the measure of arc ABC is 180 degrees, right? So the measure of arc AB. One way for us to find the measure of arc AB, let's think about the fact that measure of arc ABC is a semicircle. So this should be equal to 180 minus 32, which is going to be 148 degrees. Got it? That's the measure of arc AB. Okay, so the measure of angle COD, here's angle COD. Again, this is a central angle. It has a vertex at the center of the circle, so it's equal to the measure of its intercepted. Intercepted is what I mean by cut off, right? You intercept somebody, you cut them off. Is equal to the measure of angle COD, and it's equal to the measure of its arc, so that should be 58 degrees. And then we want to find the measure of arc CDA. That's another what? What is that again? That's another semicircle, right? That's another semicircle, so that measure should be 180 degrees. Good. Okay, and then we want to find the measure of arc AD. So again, we can do 180 minus 58. This is going to be 180 minus 58, which is going to be equal to 122 degrees. Now I want to find the measure of arc BAD. That's a little funky one right here. BAD starts at B, goes through A first, and then comes around here to D, right? Here's arc BAD. That's the big question mark right there. Well, look, we already know that arc BD measures how much? We already know that this is 90 degrees. You found that right here, remember? You found that right here. So how about if we just do 360 minus 90, okay? So the measure of arc BAD is going to be equal to 360 minus 90, which is going to be 270 degrees. Hopefully you were able to figure out what you could on your own. I do hope for that. If not, hopefully this helped a little bit. And that's the end of finding arcs and angle measures and central angles.